Okay. Today let's see the 1000 rated question. So the question says that you are given a binary string of zeros and ones, and you can perform these two types of operations: either delete one of the character or swap any pair of characters. This costs 1 coin and the swapping is for free. You can perform any number of this operation in any order. Let's say you are given a string s. After performing the operations, you will the final string will be denoted as t. The string t, the final string t after the operation is good if and only if for each index from 1 to the length of that string, that each index is not same to the previous array. What is the minimum total cost to make string t good? Okay, so the question says that you will be given a binary string s which consists of ones and zeros. Let's say this is an string. We need to make a string t such that each index of ti should not be equal to index of si, and to make t we need to perform operation. We need to start from s, and on performing operations from s will be coming towards t, right? And what are the operations? Operations are two types. For 1 coin we can delete an element, or for 0 coins we can swap an element. Okay, so from s we have to make a string t such that each of index of t from starting from 1 to the length of the final string, because after there is a deletion, right? There is an operation called delete, so it may be possible that the length modulus is length. Okay, so modulus of string s will be greater than equal to modulus of string t, because we'll be going from string s to string t by performing operations. And operation, in an operation we can also delete an element. Swapping means the length will remain same, but deletion, the length can decrease. Got it? Next we'll see how can we make it possible. Okay, so we need each element from 1 to the length of that string t to not be equal to the original string. So that means that if here 1 is present, for the same index first position we need a 0 here. For next element should be 0, next element should be 1 1 0, likewise. Okay, so we need this is a valid t, but is it? Because what are the operations? Operations are either we can delete an element or we can swap an element. So let's go step by step. Okay, so our array is 1 1, sorry, our string is, let me say 1 1 0 0 1. Okay, so 1 1 0 0 1, this is the original string s. Now we need to transform this, so let's start transforming. The first operation, we'll prefer the greedy way, right? We need the 0 coins, which means we'll always try to swap first. If there's no option, then we'll delete an element so that the number of coins is minimized. We'll try the greedy approach. So this will swap the element. So we need a 0 at first position. So what we'll do is we'll swap an element where 0 is there. So it becomes 0 1 1 0 1. Okay, next again we, from the original string here, second position should have 0, right? So let's swap this element with another element. So we need to swap this with this. So it becomes 0 0 1 1 1. Okay, now next what is next what element? 0th element, and here it is 1. Okay, this is valid. Here it is 0, here it is 1, this is valid. Here it is 1. So in the final string there should be a 0 present here, 0, but we can't produce 0, right? All the necessary zeros we have already put them here where they are needed from index 1, so there are no more zeros to swap here. So finally we have to delete this element. There's no option other than deleting this. So we need to delete this element. So the final t will be 0 0 1 1. Length of t is equal to 4. Length of s original string was 5, and as you can see our original string was 1 1 0 0 1, right? So the what our constraint was that for all indexes of t, each element should not be equal to the original element. So as you can see, this is valid. Everywhere where there is 1 it is 0, and everywhere where it is 0 it is 1. So we have swapped it. So to code this, what are we doing? We're starting from index 1, right? We're starting from left to right, because in the question has asked us for all indexes from 1 to the length of that t. So we can decrease the length of the t, but we are always starting from first position. So we'll be starting from first position, and for first position, for everywhere if there is 1, we need a 0 here. Everywhere where there is 1, we need a 0 here. Everywhere where there is a 0, we need a 1 here. Okay, that's what we need. So what we'll do is we'll count the total number of ones and total number of 0. Let's say this was the string, right? So we'll count the number of ones. The number of ones are 3 in this case, and zeros are 2. Okay, so I'll write it elsewhere. Okay, so our string s was 11001. It has 3 ones and 2 zeros, right? So what we'll do is we'll transverse from left to right, okay, from first index to the required index. Okay, what we'll do is if we find a 1 here, that means we need a 0 here, right? We need a 0, and we have a 0 available somewhere in the string. So we'll swap it to the first location, and what that means is that we have consumed this 0. So remaining zeros are 1. So it becomes 0 1. Let's say I swapped this one. Okay, I swapped this 0. So 0 1. Okay, so this was I checked through I equals to 1. For I equals to 1, there was a 1 present, so I reduced the number of 0 present. Now I equals to 2. Let's go for I equals to 2. For I equals to 2, there is a 1 present here. For that means we need a 0 to come here, and we have a 0 afterwards present. We need, while okay, let me tell you that when we are transversing through from left to right, we are changing elements, but these all elements that I am taking are present towards the right of the current index. That means, okay, let me you might not get it clearly. I'm not able to put it in words. Just a second, let me think about it. Okay, so what I mean to say is we are going from left to right, and for each number present here, we check if there is a 0. I'll say that opposite. Okay, I'll use the word opposite each and every time. I'll not say 1 for 0, 0 for 1. So 1 opposite will be 0 and 0's opposite will be 1. Okay, consider this. This is my language. Okay, so for each number we find the opposite if a opposite number is present after that element, because once we swap that element, that means that in this case we swapped, right? First element, we need a 0 here, so we swapped it. So 0 is necessary here, so we cannot take this 0 and swap it elsewhere, because this is required here. What we are doing is we are just swapping the elements, and we are checking if the opposite element is present towards the right of the selected element, because all the elements towards the left have been swapped and they have filled the constraint and they are necessary to be at that position. So likewise, now in this case I is equal to 2, so 1 is present here, we need a 0 here. in the original string 1 was present here, and this is an original string. We have swapped this first index, so this is original string, so we can check it from here only. So 1 is present, we need a 0 here. There is a 0 available towards the right, there is a opposite element present, so we'll use that. Using it means it will get consumed. So number of zeros is 0, and we have swapped it, so it becomes 0 0 1 1 1. Okay, next there is a 0 present, so we need a 1 here, right? Okay, we have already swapped this, but what that means is that it was consumed. That means we'll say for index 0, okay, for 0 we need a 1, and there was a 1 present, so we'll consume this. So number of ones will be 2, and we have, for I equals to true 3, we have checked that there was a 1 present, and we have consumed that. Okay. Okay, instead of swapping, let me just, as we can swap, right, any element. So what that means is that we'll just start to put numbers. That means there is 1 1 0 0 1 here. We need to put elements here, and we have 3 number of ones, and zeros we have 2. Okay, what this is string S, and we need to make T. We are making this T by swapping as many times as we want, right? And swapping means that we can change index of any number. We can put a number anywhere, so we can directly arbitrarily put the values. That means we have 3 number of ones and 2 number of zeros, so we'll directly start putting as per requirement. Okay, so 1 is present here, we need a 0 is also present, so we'll consume this and put a 0 here. Next 1 is present, so we need a 0. 1 is also 0 is also present, so we'll consume this 0. The number of zeros left is 0, and we put a 0 here. Next we need a 1, so we put a 1 here, and we'll consume 1 from here. Again we need a 1, we'll consume and put it right here. Okay, now we need a 0 here. In this place we need a 0, but there are no zeros available, right? There are no zeros available. That means we can't swap any element. That means we need to delete elements. So this was troubling us, right? The 5th position, 1 2 3 4 5, right? The 5th position is troubling us because we have no 0 to put here. So what we'll do is we'll just delete the 5th element in our array T. So there is no element here, so we'll put an X here. This X, putting X here, costs 1 coin. That is a greedy way. This is the greedy way, and coding it is just like how explained here. We'll find the total number of ones and zeros, and we'll iterate through the S, iterate through here. And whenever we find a 1, we'll consume a 0 from the total. Whenever we find a 0, we consume 1 from the total. And if we need an element and there are no elements present, that means that index needs to get deleted, and the numbers after it, let's say there was 1 1 here. Okay, so again we need a 0 here, we need a 0 here, but our constraint says that from index 1 to the length of T we need all the elements opposite. So that means that if any one of the element is falling short, the elements after that should not be considered, because from 1 to total T we need that constraint to be followed. So if we find if we fall short somewhere, only till there we can make an array T, and the numbers after that needs to be deleted. So let's look at the solution. So I have taken the input as a string, and wherever I find 1, I have increased the count of 1, and if it was 0, it was a binary string, right? So the other case is only 0, so I'll increase the counter for 0, and again I'll iterate through the loop. Wherever I find 1 and the count of 0, for 1 we need 0, right? So if I find a 1 in the array, in the string, and the number of zeros present are also positive, that means I can consume that 0, so I'll consume that 0. Else again similar for 0, if I find a 0 and the number of ones present is positive, I'll consume that 1. And if else I'll break, because what that means is that either of this has become negative, and that means 0, that means I cannot consume anything. Even if I have found a 1 or 0, I have no opposites to consume, so I'll break. And the final answer will be the number of deletions, right? So what will be the number of deletions? The final deletions will be total count remaining, because whatever I have consumed is going into T, so whatever is left is what I have to delete. So I have directly put count 1 plus count 0, because when will it break? When either of the count 0 or count 1 becomes 0. That means if it is 0, that means I cannot consume it, so it will break. And once it will break, that means count of 0 is 0. The remaining numbers I have to delete. What are the remaining numbers? That is count of 1. Got it? The being consumed goes into the T part. The remaining part is what we need to delete. Got it? Okay. Thanks.